Question 3 is asking you to compare two different ions. The ions are Br plus 81, Br plus 79. Now, the kinetic energy of both of these ions must be the same, and the kinetic energy is equal to half md squared over t squared in both cases. They both have to be equal to each other. So what we can do is identify any values that are constant, and we can actually remove them from these two equations and then combine them afterwards. So we know that the two EK values must be the same, half and half are the same. Now the mass is different, 8179. The distance of the tube, however, is the same. So what we're left with is the relationship of the mass of the first ion divided by its time squared is equal to the mass of the second ion divided by its time squared. If we substitute in the values now, 81 divided by the time taken for this one squared is equal to 79 divided by a t squared value. Now, you might be wondering why we haven't converted these into kilograms. Well, we don't need to do it at this point, because to convert these into kilograms we need to divide by Avogadro's on both sides and then divide by 1000 on both sides, which effectively cancel each other out anyway. If we rearrange this equation, we find that t is equal to square root of 79 over 81 multiplied by the time squared. And we should find that the answer is 2.79 times by 10 to the minus 5 seconds. Now, before we move on, if you just compare the time taken for a slightly smaller ion compared to a slightly bigger ion, you'd expect them to be of the same order of magnitude, which they are, but the smaller one to be slightly faster, which it is.